Yay!
Yay! Okay, now we've done so many rings, integrated so many rings to find the electric field, we're ready to do a half ring. So now this should go quite a bit quicker because there's a constant sort of a pattern that we keep doing. So let's find, if we have a half a ring, a little semicircle of charge plus Q, let's find the electric field right there at the center. First of all, if you look at this, you sort of know that the overall electric field is only going to have an X component, right? Those Y components are going to cancel out. Because like from the little dq, the little piece of charge up there, I'm going to have an electric field going like this, right? And then when you're down here, its partner down here, you got an electric field going like that. So those Y components will cancel. You're only going to get an electric field in the positive X. That's cool. And we already know how to start this. We already know that this is going to be the integral. Let me skip a step and say that it's k dq over r cubed, r vector, right? We're going to sum up all those little bits of charge, and we're integrating around a half circle, so it kind of seems right that we're going to go from 0 to pi. But again, I've got dq and I want d theta. I want to integrate over theta, so I need to change variables from dq to d theta. And our standard trick is to say a little bit of charge compared to the whole charge is like a little bit of angle compared to the whole angle. The whole angle I'm interested in is pi. All right, so there we go. And what about our r vector? What's that going to be? R vector, well, if I'm up here, here's my little dq up here. If I'm up here at this point, how am I going to get from there to the origin? Well, what I'm going to do is I have to go over a certain distance in x, right? But that distance in x I can write in terms of theta. I can write it as big R times, oh, that's a vertical angle, right? So this is going to be r sine theta. That's how much x I have to go over. And then to go down to the point, down to the origin point, I have to go the y component, right? Minus the y component, which is minus r cosine theta. Notice that works out great. If theta is greater than 90 degrees, then the cosine of something greater than 90 degrees is negative. So those two negatives are going to cancel, and it's going to tell me that I have to go up, which is right. Yeah, that's kind of neat. But anyway, it doesn't even matter because all those y components are going to vanish anyway. So I know that the only thing that's left is going to be that r sine theta, and it's going to be in the x direction. So I think I'm just sort of ready to go. So the electric field is going to be 0 to pi, and let's see, dq is going to be q, so I'm going to have a k q d theta. I'm going to have a pi on the bottom. I'm going to have an r cubed. Oh, so what is r? As I go around the circle, the distance, this distance, which is just little, usually we call it little r, right? But that's just big R, and it's not changing. That's just a constant. So this is actually going to be pretty easy. That's just going to be big R cubed. And then I have my whatever's left from the r vector, and all I have is that x component. So it's going to be r sine theta. Okay, well, let me bring the constants out front. So it's going to be kq over pi r squared, because the r's cancel, 0 to pi sine theta d theta. Well, that's a pretty simple integral to do, as long as you don't get screwed up by the signs, SIGNs, which I always do. I can never remember trig functions like derivatives, integrals, which one is minus, which one is plus. This one I think I remember. So the integral sign is minus cosine, right? If not, I'm going to get a negative answer, and then I'm going to know I was wrong. So let's see. This is going to be kq. Okay, this means kq over pi r squared. So this is going to be minus cosine theta from 0 to pi. And what is that? Okay, so we have to be careful with all these signs. Cosine of pi is negative 1. So that's an overall +1. And then subtracting a minus cosine of 0, which is 1, right? So I'm going to have a kq over pi r squared. And I'm going to have a 1 minus 1, like that. I think that's right. So that's going to give me an overall 2. So my electric field is just going to be 2kq over pi r squared, and overall that's going to be in the x hat direction. Neat. I think that's it. I think we did it. So always it's the same pattern, is that you have your little bit of charge that's on your your shape. You have your little bit of charge, and we're always just integrating little bits of charge, and then we always have to do our little change of variable. And once you do all that and plug it in, then it's basically just sort of Calc 2 all the way to the end. So hopefully you're starting to, after you do a few of these, you start to sort of recognize the pattern that you can apply. All right, next.